Benefits of the modern microservices approach. To process increasing amounts of data, the classic approach needs bigger, faster computing. This approach is called scale-up. Scale-up was the dominant way of scaling when Moore's law was alive and well, and silicon and compute performance was doubling every 2 years. With the modern approach, computing performance is increased simply by adding more nodes to the infrastructure. This more flexible approach to scaling is called scale-out, and it circumvents the slowdown of Moore's law. With the classic approach, the computation you need to perform needs to be matched to your hardware. Since the computations have varied requirements on hardware, you need to oversize your hardware to account for the superset of requirements, and that's wasteful. With the modern approach, you can easily run a microservice on a composed set of disaggregated resources matched to its specific requirements, leaving unused resources for other microservices. With the classic approach, whenever there is a failure, hardware or software, not only is isolating the fault a complicated and time-consuming process, but addressing the issue often requires interrupting the service. Mitigating failures requires a redundant big iron, which is an expensive solution. With the modern approach, when a failing microservice is detected, a new instantiation can be created in its place. Software is constantly evolving, whether for bug fixes or new improvements. Deploying new software while it is simultaneously running is nearly impossible with the classic approach. With the modern approach, however, it's easy. The microservice with the new software is instantiated. Both old and new microservices coexist until all requests are intended for the new service. Then the old service is removed. This approach allows for rolling upgrades of software. With the classic approach, performance is optimized by counting instructions and recombining functions to get the benefits of inlining, and that extends to recombining functions across layers as well. With the modern approach, all that needs to happen is a straightforward matching of bandwidth. If a microservice becomes the bottleneck, simply instantiate more of it, and all that can be done automatically by the control plane. If after applying all possible software techniques, more speed is still needed, you can turn to hardware acceleration. With the classic approach, discrete accelerators can be used, but the synchronous nature of the architecture reduces the benefits. The microservices, on the other hand, are inherently queue-based and asynchronous, allowing entire microservices to be easily implemented in hardware.